Okay, this video is going to show how to create a helical sweep, and what we're going to do here is, in this representation of a screw that I have, a socket head cap screw, we're going to create the threads in it. So what I'm going to do is I'm going to turn my datum planes on. I'm going to come up under the Insert tab and go to Helical Sweep, and we're going to make a cut. And we're going to accept the default attributes for a right-handed thread, and we're going to select the datum plane, one of the ones that are vertical through it, and we'll say OK and accept the default. Now we have to define a sweep profile. So the profile is that we're going to want a thread that's going to run along this outside edge of the part. So I'm going to click on a line, and I'm just going to come down here and let my line come horizontal to the part, up and down, and then I'm going to use the coincident constraint to bring my part, bring the line touching the part at the top and bottom where I want the threads to begin and end, and to be coincident with the outer edge of the part. And then the next thing we need to add in is we need to physically put in a center line. So coming over here to utilizing the center line tool, I'll just select the top. So all I'm doing is selecting on the axis here that's defined by the front and right planes. So one click here and you'll see that makes a line essentially going off to infinity. So I'm clicking at the top and then grabbing the bottom and just clicking again, and that defines my center line. And with those two, I've defined the sweep profile. So I'll say that I'm done. Now the pitch value, this is about the dimensions of a 1/4-20 screw. So if we're going to make a pitch of 20 threads per inch, that's about 0.05 or 1/20. So that's going to be my pitch value. We'll say that we're done. Now you see here's where it's starting my thread. This is where it wants to put the coordinate axis. So I'll zoom in here, and the thread we're going to make is going to be a triangular thread with an angle of about 60 degrees. So what I'm going to do here is click, make my triangle. Let's put my dimensions in. So I need to put a dimension here and here. We'll make that 60 degrees, and we will likewise say that this one is 60 degrees. And we're going to make the total height of our part 0.045. Let me drag this part out here. So there's our shaded part. I see I have up here in the upper left hand corner the shaded section icon chosen, so it shows that's my shaded area. That's going to be the cut section, and it's going to be revolved around my axis at a space of 20 threads per inch, or it's going to move down a distance of 0.05. You see the dimension here is 0.04, so every time it revolves around, it'll move down a total distance of 0.05. So we'll say that we're done with our sketch. And now let's zoom in. It's defining the material that's going to be removed. It's going to be inside my section, so we'll say OK. And when we get to the top here, it says all elements have been defined. So again, we'll click OK. And there it is. It has generated our threads. So there's our part. Let me turn off my datum plane so we can see it a little bit better. And that's a nice bit of a screw. Now you can see there's one little problem with my screw up here that doesn't look quite right, is that the thread ends abruptly here. So I'm going to actually, just for cosmetic purposes for a screw, I'm going to add in a solid part here. So what I'm going to do is I'm going to sketch onto that plane. Now I'm just going to grab a circle and come out to my edge over here, and I need to put my dimension in. So the dimension here is 0.25. I'll say that I'm done, and I'm going to extrude it. I'll extrude it as a solid. Let me grab my piece here and make it about 0.125. And I'll say OK. And that makes it look a little bit better, more like a threaded screw. Now again, this is not an exact representation of a 1/4-20 threaded hex cap screw, but it's a nice representation of it. Alright, so that's the swept cut, the helical swept cut.